Hi there. The binomial theorem gives us a really handy way to multiply out things like x plus y to the squared. Well, you go, well, that one's not hard, and I agree with you, but what if I asked you to do x plus y to the raised to the 8th power? Then you would not be quite so inclined to say, oh, that's easy. So what we're going to do is we're going to look at patterns, and I'm going to give you two different ways to expand these binomials. We're going to use the binomial theorem, and we're also going to use it with Pascal's triangle. So we'll use it with combinations, and we'll use it with Pascal's triangle. So if I were to multiply out x plus y quantity squared, it looks something like this. And some of you might say, do I FOIL that out? And I would say yes to that. So what I'm going to do is I'll multiply the x times everything and multiply the y by everything, and then I'm going to combine like terms. And what you'll end up with is something that looks like this, which is not too bad in itself. Then I'm going to just expand it just one step. I'm just going to ask you to do one extra thing. I'm going to ask you to do this. And it increases the difficulty quite a bit. And you would say, yuck, I don't really want to do that. Because what you're going to have to do is you're going to have to multiply two of these little guys. And then you're going to have to multiply it by the x plus y. So you'll end up with something like x plus y times, and I've already done this one here, so I'm just going to write it from above. X squared plus 2xy, xy plus y squared. Yuck. Now I have to take the x, multiply it by each of those, take the y, multiply it by each of those, and then combine like terms, and what you'll end up with is something that looks like x cubed, and I'm not really going to do it because it would take too much time, and you can do that at your leisure. Just pause me if you want to, if you don't believe it, and you would see that this is what you would get. And you go, yuck. Then if I ask you to do x plus y to the 4th, you don't even want to do that one, much less this x plus y to the 8th or x plus y to the 10th. But what the binomial theorem is going to do, it's going to give you a way to expand these things really quickly. The hardest part, if you'll notice, would be coming up with these coefficients here, because they kind of seem pretty random, really. So I'm going to look at, let me change back to my red pen. I'm going to look at x plus y to the 4th. I'm going to go ahead and tell you what it is. Let's look at the patterns of our exponents first. I notice that every time I'm going to have x to the 4th plus, I'm going to have some number there, and I don't really know what it is, so I'm going to leave a space. My x is going down by 1. So you notice 3, 2, 1, none of them. So it would be 4, 3, 2, and then a 1, and then none of them. And I guess I'm going to have plus sign, and I need a coefficient in there, so I'm going to just leave some space on either side of these guys because I need a y in there as well. So just leaving myself room. Let's look at what the y does. None of the y's, 1y, y squared, y cubed. Okay, no y's. So this one would be 1y, this would be y squared, this would be y cubed, and this would be y to the 4th. Notice that your exponents always add up to 4. 4 and none of them are 4. 3 and an understood 1 are 4. 2 and 2 are 4. 1 and 3 are 4. And of course there's your 4. Now all I need to do is figure out these coefficients. And that's what the binomial theorem is going to give you. It's just going to give you these coefficients. So I could tell you that this x plus y to the 8th is going to look like, without writing in the coefficients, and in a minute we'll figure out how to do the coefficients and something like that, but x plus y to the 8th is going to look like x to the 8th plus some coefficient, x to the 7th y, plus some coefficient, x to the 6y squared. Notice how they add up to 8, plus some coefficient x to the 5th y cubed, plus some coefficient x to the 4th y to the 4th, plus because these things are very long, some coefficient x to the 3rd y to the 5th, plus some coefficient x squared y to the 6th, plus some coefficient x y to the 7th, plus and y to the 8th. So if I could figure out what these coefficients are, life would be so good. And see, I'd already be done. I could just tell you, I just plop those coefficients in there, be done, and be so sweet. All right, so I'm going to go ahead and give you some methods for getting those coefficients. What I have up for you now are the first, I guess you might say, 6 expansions, starting with the 0, 1, 2, 3, and carrying on with there. You can look at my exponents and notice how the x's go down by 1s. The y's go up as we go across. That's the pattern that I want you to follow so that we can just plop our coefficients in there. You must follow this pattern if you just want to throw coefficients in without multiplying it all the way out, which is what I'd rather do. I don't want to multiply this out. All right, so I think we looked at x plus y to the 4th, and here are the coefficients that belong in there. Now, it's going to look pretty crazy. Let me show you this thing right here. This is what is going to get you the coefficients, and it is this little guy right here with the C next to it. That's what actually is going to get you the coefficients. The binomial theorem itself is this big bunch of crazy looking stuff, but this gets you the coefficients. So, and they even say coefficient right there. So I'm just going to write coefficient to reiterate. This is what it's going to get me, the coefficients. And notice that my coefficients are these numbers right here. We're going to go ahead and understand that the very first one is going to be a 1. Notice how they're always 1 down through there. The next one is going to be whatever happens to be my n. So if n is 3, there's a 3 in that first spot. At the very back end, this is going to be a 1, and this is going to be my n. Now I'm just looking at coefficients now because we kind of have the pattern of what the exponents need to do. And you look at that coefficient formula and you think, well, that thing is really crazy. But with your TI-83, TI-84 calculator, you really don't have to use this formula. I know that's very sad, but you don't have to use the formula. What you're going to use is a pre-programmed set of buttons in the calculator. So I'm going to show you how to get to those. In order to get these coefficients, what I want you to do is take your TI-83-84 calculator, and you can do it with either, and I want you to find the button labeled Math. This combination function is in the Math button. So find the Math button and depress that Math button. Then what I need for you to do is scroll over to probability here. So scroll over to probability, and we're going to want this particular function here. So that's what we're going to want. All right, so now that you've found it, do a yellow quit or blue quit and get out of there, and we'll actually get one of these coefficients. Let's say that I want this coefficient right here. This is how I'm going to get it. Now, notice in my syntax here, I need an N combination R. And what that means, we are going to be able to find our coefficients using this combination. N is going to be our exponent. So in our case, we're looking at the 4 right here. So N, C, and R is going to be the term number. So for our purposes, this will be term number 1. This right here will be term number 2, and the next one will be term number 3. Just understanding that the coefficient in front of your very beginning and your very end one are always ones. So in your calculator, you're going to hit your math button. You're going to scroll to probability, and you're going to get to this NCR thing. So what we want in our screen, in our main screen, is going to be N, which is 4. So if you will, hit your 4. Then I need you to hit math, scroll to probability, then get to your combination, and then hit enter because I want 4N, oops, not the, yeah, well actually the N will be sitting on your calculator, CR, and then we're going to ask it to do term number 1 so that we can get this very first one, which should be equal to 4. Then we will need to do, let's get the next one. We would hit 4, math, scroll to probability, get your combination, and then we would want term number 2, and that should be a 6, and then 4 NCR for term number 3, and that should also be a 4. And that's how you're going to get those coefficients using your combinations. And remembering, let's just look at another one just so that you can figure out what's going on. This would be term number 1, so that one would be a 5 NCR1. This one would be 5 NCR2, 5 NCR3, 4, and so forth. So this would be the first term, second, third, fourth. Pascal's triangle is pretty handy. Pascal's triangle is created using a little, let me write down Pascal's triangle. A little procedure, what you would do is you write down your first 1, then you put a 1 on either side, and then you make the next rows by adding the, you'd add the 1 to 1 and get a 2, you'd add the 1 and 2 and get a 3, the 2 and 1 and get a 3, the 1 and 3 to get a 4, the 3 and 3 to get a 6, the 3 and 1. And this is another way to get these coefficients. Notice that this row 4 here corresponds with the coefficients that are in this row having to do with the exponent of 4. It's not really the 4th row, but it's actually, if you count 0, 1, 2, 3, 4, it is the row belonging to exponent 4, we might say. And if you'll notice, the row belonging to exponent 5 would be all the coefficients for this guy here. You know, Pascal's triangle is handy as long as you don't have to create a triangle that's, say, greater than 10. If I have to create it, I don't know, really creating one greater than 7 I don't want to do, and I'll use a combination. But it can be done, you know, so this is just another way to create your binomial expansion. Alright, now let's pretend, let's say that we had x plus, how about 3 raised to the 4th. I know what an x plus y expansion is going to look like, so I'm just going to kind of slide that in up here at the top. X plus y to the 4th is going to be x to the 4th plus 4x cubed y plus 6y squared, x squared y squared plus 4xy cubed plus y to the 4th. Alright, that's what this one would be. Woo! Got off my little screen there. Okay. Now, let's pretend instead of a y, it's a 3. Alright? No big deal, really. It's just wherever there's a y, I'm going to put a 3. Now, watch your exponents. Wherever there is a y, I'm going to put a 3. So this should be a 3. 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 And then just multiply. So it really doesn't make, you know, it really doesn't change things too much at all. It's going to be x to the 4th plus, and let's see, that's a 3 there, so I've got 12. X cubed plus, that's going to be 3 squared, so I have to do 6 times 9, which is 54. Plus, and this is going to be 3 cubed. 3 cubed is 27. So that would be 108. And then just y to the fourth. Oh, I need to do that 3 to the fourth. 3 to the fourth would be 81. Okay, so it really doesn't matter to me if it is x minus 2b, let's say, to the fourth. Where I once had a y, I now just put a minus 2b, just changes the signs. So I'll do that real quick. Alright, I just went ahead and wrote this down to save some time, but you're just going to put a negative 2b in wherever there's a y. And I just wrote down the fourth degree binomial expansion. And then you're just going to multiply all this crazy stuff out, and then you'll be done. So multiply it out and combine, where you can, and you'll be finished. I'll go ahead and do one for you. Alright, multiplying this out, it's going to be minus 8x cubed b. That's going to be 6 times negative 2 times negative 2 is 4, so that's going to be plus 24x squared b squared. Then I'm going to have negative 2 to the third is negative 8 times my 4 is minus 32x. And then I'm going to have plus 2 to the fourth, negative 2 to the fourth rather, is 16b. Oh, I forgot my b cubed. Get in there, little boy. Alright, and then b to the fourth. All done. And that's all there is to it. Of course, if x were something other than x, you would just replace x, just as I've done y. It's really similar.